There we go. All right, thanks for coming out, guys. Thanks, SalesLoft, for sponsoring. SalesLoft provide the food and beer for tonight. Yeah. 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 $70 million of pizza. Yeah. So as far as announcements, we're going to be doing the meetup here next month. We've got some tentative speakers lined up, but if you're interested in presenting something, hit up me or Dennis, or hit us up on Meetup or Tech44. Let us know what you're interested in, and we'll talk it out. And so open forums, anybody hiring anything relevant for Kubernetes right now?
Kubernetes, DevOps engineer, part-time, 5 hours a week, 10 hours a week. Must have a full-time job, and front-end engineers developing microservices. We're building an AI platform that runs and optimizes applications in the cloud. And that same recommendation engine optimizes the performance from a cost standpoint as well. We've already been committed into a Microsoft accelerator funded by them, and also have some funding from AWS and Google. So if you're interested, we're a team of 16, and again, you must have a full-time job and only 5 hours a week or 10 hours a week in your spare time.
So that's real theory, picking people up for 5 or 10 hours.
Real theory.
You forgot to say the name, buddy.
Yep, we're hiring. I'm fan, we're volunteer. We do crazy stuff with airlines to try and stop people getting like dragged on flights and beaten up and stuff like that. And other stuff. We're actually looking for like full stack developers, but we do like full stack including DevOps as well. So we're all deployed in Kubernetes. We have multiple instances all over the world, enterprise kind of fun stuff. So Kubernetes is joining into like really old school, multi-billion-dollar like enterprise companies, which is a fun game to play. So we're hiring at the moment. We're Y Combinator funded. We have an office here in Atlanta, just downtown. About 20 people total at the moment, about 14 in the Atlanta office. So we're interested in coming to Atlanta. More time. Volunteer.
And I can vouch for Volunteer. They're a great company. And several people that work there.
Anybody else? No? Okay, SalesLoft's also hiring systems engineers right now. So you're kind of straight up DevOps, quote unquote, people doing heavy Kubernetes work. Again, hit up me or Nora back there's a great person to talk to if you're interested in us for any roles we have open. All right, cool. With that, Joe is here to talk about doing Kubernetes policy as code at T-Mobile.
Hey everybody, Joe Searcy. I'm a principal architect on the platform engineering team at T-Mobile. We work in all things platform related, from Cloud Foundry to Kubernetes, function as a service, everything that sits on top of those things. Before we get started and jump in here, I just want to kind of ask some questions, get a show of hands. How many people are running Kubernetes in production? Okay, out of you people, how many of you administer the Kubernetes platforms as well are represent the primary consumer of the platform? You write the code too that runs on there. Okay, so much smaller number of people. How many people are using things like role-based access control in Kubernetes? Okay, all right, a few hands there. And how many people are using some sort of policy as code tool today? Okay, one. All right, so jump in. Policy as code for Kubernetes. Call this rolling out the magenta tape. So red tape, it's bad, right? We all have this sense of a negative connotation when it comes to policy in the IT world. We're engineers, we like to build things. We don't like things to stop us from twisting knobs, doing things like that. We're used to policy being things like change control processes and audits and things of that nature that are run usually by another group of people. But we have a lot of these things where some of the negative connotations come from is we try to do something really cool using some new technologies, and we might hit a bump on the road and say we have an outage or something like that. And then somebody way up the chain says, oh, I'm scared of this thing, knee-jerk reaction, we don't do that anymore, And now we have this kind of arbitrary policy that we can't do thing X because one time, however long ago, we did it and it didn't work very well, right? I think most of us have probably all been there. Subjective decisions. I don't think anybody has policy that's enforced by robots. So the human factor comes into play there. And, you know, when you have people are inherently fallible. And so you get, this guy has a friend on team X. He doesn't really like this guy on team Y. So he lets these guys slide a little bit on, you know, a couple things here and there, but he doesn't let these guys slide. So it's kind of, you know, fallible in the practical sense there. And it's also very manual. I'll show you a slide in just a second that shows what most of us are probably familiar with when it comes to some type of policy definition and enforcement in a traditional sense. It's typically run by people, so that takes time. And then it's decentralized. So T-Mobile's a big company, and I'll speak for us. I don't want to throw anybody else under the bus. But we have entire pieces of our organization at large that operate almost as individual companies in some cases. And so they have their own IT teams. They have their own people making policy decisions and things like that. So we define policy over here in organization 1. Organization 2 has its own policy. Sometimes they match, sometimes they don't. So how do we go through and fix these things? And again, this is kind of that legacy policy workflow where we have a group of people that are usually defining the policy that aren't the people that are actually doing the hands-on work to figure out what the policy should be. And then we have some type of, you know, asynchronous, very slow process to get things reviewed, get a response back and say, everything's okay. Now you can go forward and actually do the work. So to fix that, we bring in magenta tape. T-Mobile, everything that's magenta is better, right? But this starts to bring in the principles of policy as code. Let's take some of these things that are run by people and some of these arbitrary decisions and throw them away. Let's make policy something meaningful. So informed peer-driven policy. This is policy written by us, the engineers that are doing the hands-on work, that we see the things fail, we see what we do wrong. Oftentimes we know that we did it wrong and we know what we need to do to fix it so that we can overcome that and kind of erase that from happening again in the future as best as possible. Objective decisions. Code doesn't care who you are. It's going to enforce a policy the way you tell it to enforce the policy. Infinite scalability, and I use some air quotes here on infinite. Obviously, this is within the realms of resources. Everybody's got to pay a bill at the end of the day, and you know, CPU, memory, and storage cost money. So, not really infinite, but if you got the money for it. And then centralized practices, and this is an important concept that I'll touch on a little bit later when we kind of dive a little bit deeper into the specific mechanisms for enforcing policy here, is you need this to be defined centrally. And that goes into the kind of, you know, objective versus subjective pattern there, is you define policy once and it gets applied everywhere. So the concept of policy as a code, we have a centralized place where we define these policies. We have a centralized mechanism to enforce those policies. And some of the benefits that this brings to the table is instant feedback, right? You don't have that slow, manual, people-driven process to say, let me submit something to a queue, wait for those people to approve it, move it to the other queue, and then eventually get a response back. This happens immediately. And then once it's written, the policy is enforced automatically. It doesn't require any type of manual review. And this can kind of take you out of that concept, what we're probably all used to, of continually monitoring for policy violations, and we just stop them at the front door to where we don't have to do all those mechanisms to continually review. Now, I'm not saying don't still continually review, but it becomes less of a problem and less of a time waste. So hopefully we're all familiar with Kubernetes at this point, but I want to take a second here to kind of boil it down into 3 chunks. Abstracting the underlying infrastructure, making CPU, memory, and storage consumable resources via an API. Managing your applications like cattle instead of pets. The individual things don't matter as much anymore. And then a declarative things. I want thing X to look like this, do whatever it needs to done at any time of the day, any day of the week, any day of the year to make it match that. But the big thing down at the bottom is a consistent user experience. And when I say this, I mean whether you're running on-premise, in the cloud, you know, AWS, Azure, Google, anywhere out there, consistent user experience. And this goes into some of the things that were kind of core tenets to how we formed our Kubernetes group at T-Mobile. So TKE, this is T-Mobile's Kubernetes engine. I know everybody's got a, you know, XKE, right? But we did this because we wanted to brand our offering internally to show that we're doing something more than just shipping an off-the-shelf product. So right now, TKE is an on-premise solution. We're expanding into the, or we have in our roadmap to eventually expand into the cloud. And that goes into that consistent user experience thing. We want to drive our decisions around what tools we use and how we manage our environments to be that it doesn't matter to our customers where they land on a cluster, whether it's in data center 1 on-premise, data center 2 on-premise, cloud provider 1, cloud provider 2. It's a consistent experience. So in that, we also wanted to provide a similar integrated experience to what you would find in a major cloud provider. This is hard to do on on-prem clusters. There's a lot of things that people take for granted when you're working in the cloud. You know, your elastic load balancers just kind of work. Things like certificates and DNS just kind of work. Exposing services to external networks just kind of works. Those are all problems that we had to solve. And all that to say, we bundled that up to make TKE. But the last thing that I want to mention here is one of our core tenets is, and the way, the reason why I kind of put this graph this way is we did not want to be opinionated about how our developers write code or deploy code. Because let's be honest, at the end of the day, we build Kubernetes for developers. They're the people that are writing the apps and making money for the company. And the whole concept of Kubernetes is to make those things simpler for them. Writing code is all they should have to worry about. So we want to be there, we want to support them, but we don't want to get in their way. And so that becomes an important concept when you talk about introducing something like policy to what's kind of built out to be an open environment. So we wanted to be very selective about the types of policies that we implemented here so that we don't start to develop anti-patterns for what the whole premise of moving to a container as a service platform like Kubernetes is. So let's talk about a little bit about how we got here. Why do we even need policy as code for Kubernetes? This sounds complicated. This sounds like, you know, you're trying to search for a solution to a problem you don't have. Well, it's a very real problem, and we hit it pretty quick as adoption started to ramp up for our internal consumers of Kubernetes. So again, we wanted to have a very hands-off approach. We wanted some guardrails to be out there, but we didn't want to be super opinionated. We have Pivotal Cloud Foundry out there, which is a super opinionated platform as a service. We have that. This is supposed to be contrasting, to be kind of open and be able to do some things that Cloud Foundry isn't necessarily good at. So what we started out, and we said, hey, developers, come. We have this new platform. Use it. They're like, well, how do we use it? Okay, well, here you go. Here's some things. Here's how you do thing X, things Y. Here's some documentation, frequently asked questions, so on and so forth. And people start, okay, we like this. Let's deploy. Let's deploy more. Let's deploy more. Okay, so now we've got a bunch of stuff running out there, and we started to see some of the same problems pop up across most of our customer base. So as they adopted things, it's really easy to take something, containerize it, and get it to run and accept traffic. Now, is that highly available? Is it secure? What happens when me as a platform administrator goes to upgrade the platform itself? How does that affect the application? I've got all these people adopting it. I go to update my platform and all the applications goes down. Has that really solved anything? Has that made it better than the legacy bare metal and VM world? No. So we started seeing our customers struggle with this, and we wanted to come up with a solution of how we can prevent this without slowing them down or getting in their way. So talking about some of the specific policies here. Does your workload have a liveness probe, a readiness probe? Have you deployed a pod disruption budget? And does your pod disruption budget make sense? Have you done something crazy like specified max unavailable is, 20 20% and I have 2 pods. You know, like that doesn't make sense. It doesn't compute. It's going to block us when we go to do platform upgrades. Things like PVC reclaim policy. Did you leave it at delete? So that when you say, hey, this time I'm going to delete that deployment and then add it back out there, wait, what happened to my storage? It's gone. So different things like that. And the kind of list goes on and on. It's really, these are things that are applicable to you guys. And again, there's a couple things that I want to make like really clear here. This can be complex, but when you go into defining these policies, these should be things that you see people making mistakes on. It's good to anticipate some things, but I think there's a fine line of reacting too soon and causing more problems than you're fixing. And again, we don't want to slow people down. We have this crazy guy that leads our company that likes to, you know, shake up the market and do all kinds of things in our uncarrier movements, right? And so our ultimate goal is to take an idea to implement a new feature for our customers and have that be in production in customers' faces by the end of the day. Now that's been a big change and a big process. Kubernetes has helped that. And features like this have helped us make that sustainable and available. So talk a little bit about where we started in our policy as code journey for Kubernetes. This is an idea that I personally had for a while now. And I've gone through a few different iterations of what this might look like. I've talked to several people in this room at different times after meetups about how they're doing certain things with their applications and stuff. And have just kind of chewed on this idea for a while. At first, it was like, hey, CI/CD conformance tests. Let's build a conformance test library. And let's say, hey, developers, go submit your workloads through this pipeline and it'll spit out a report card. You passed, you failed. Well, that's great in theory if you can make all of your developers use it. They don't have to use that. They use Helm, they use, you know, kubectl apply, they use some other tool out there, Drone, to drive applications to Kubernetes. So yeah, you got the CI/CD pipeline, it looks nice, it does some cool things, but I don't have time to slow down and see what that is. Then I got into what some people have, which is using CRDs to abstract a lot of the common information that goes into workloads. So if you're a software as a service company, this is probably something that will really benefit you, where you kind of run one app, but you run a million copies of it. And things like the names, maybe the network pieces, API endpoints, those things change, but the underlying code doesn't. That's awesome. I wish I lived in that world. We've got a bazillion applications that are like legacy, basically the anti-pattern of what you'd ever want to run on Kubernetes, but my gosh, we're driving it to containers and we're running it on Kubernetes for better or worse. So CRDs didn't really fit a pattern for us, because as soon as we started to define those things and abstract those things, we got a new customer and they need to do this other thing differently. Okay, go back and rewrite the CRD. Oh, we got a new customer, rewrite the CRD, so on and so forth. And it just wasn't feasible for us. So I was like, okay, all things cloud native and such, somebody's already solved this problem, right? Like I'm not a super smart guy. Somebody out there has already done this. And they have. But they haven't done it exactly the way that we wanted it done. So there's tools out there like kubesec and Sentinel. Sentinel is, I believe, from HashiCorp. And it works really great if your entire management of your infrastructure and cluster lifecycle is done using HashiCorp tools. It builds in and that gates everything, all the tools and everything. It works really cool. We don't use those tools, so it wasn't useful for us. And then there's kubesec. And I don't want to bash anybody or anything like that. The tool is really awesome. They did it in exactly the way that I wanted it done, which is I've got an API endpoint that I can submit my workloads to through something like a CI/CD pipeline before I ever get to the point of deploying to Kubernetes, and kind of get that report card grade before I go and hit a wall of being denied at Kubernetes layer. In addition to the admission controller inside Kubernetes. Sounds great, perfect world, right? Except for the fact that they have an open source admission controller, but the actual policy engine and policy definitions are closed sourced behind their wall. So the way that the admission controller works is they capture your request, send it off to their server, grade it, and then send the response back to the Kubernetes API server. Now, if anybody can tell me how that sounds secure, I'll buy you coffee. So that wouldn't work for us. So I was like, admission controllers is definitely the way to do this. And I gave another talk previously here to this group about kind of building out a really simple admission controller. And this kind of builds on that to get into something a little bit more advanced. But quick overview for admission controller. It's a way to kind of intercept requests to the Kubernetes API, implement your own custom logic, and give it a thumbs up or thumbs down for an allow or deny. So where are we at now in our journey? So mentioned TKE, T-Mobile Kubernetes Engine. Well, TKEV or TKEV, this is the TKE validator. This is our in-house built admission controller. We see version 1, all the way over to the right, we see version 2, and then we have this thing called OPA in the middle. And this is another key piece of what I want to talk about today. This is the Open Policy Agent. And I'll go into a little bit more detail about what that is, but essentially Open Policy Agent came along and kind of did this exact same thing that I wanted to do, right? At the point now, we had kind of full steam ahead with our own internal tool. We didn't want to slow down with that. But obviously, if we don't have to write and maintain the tool, it's a better world for us. That's more hours I can sleep at night, and I can focus on just writing and maintaining the policies at that point. So as we go forward in the development of our tool, we're developing it against OPA in the same vein, in parallel, and hopefully either merge some of our customizations into the OPA project itself, or open source TKEV in general, and have the community help us kind of build and maintain that going forward. So let's talk about TKEV a little bit. Again, it's a custom Kubernetes admission controller built internally at T-Mobile, and specifically to enforce policy as code for Kubernetes. Generically developed, it's Python using like Flask to generate the APIs and stuff like that. It's pretty simple overall. It's purpose-built for Kubernetes right now. We're looking at potentially trying to expand it and bring in Cloud Foundry with that too, but Cloud Foundry doesn't have a direct one-to-one similar concept to an admission controller, so we're gonna have to get creative in how we do that. And then there's some flexible integrations and customizations that we've done on top of just a general admission controller. So one of the things that I think we can all probably relate to is we don't, nor do our customers, nor does our management really like being told no. So with everything, it's like take a concept like chargeback. Does everybody just go straight out there and do chargeback? No, they do showback and then shameback and then maybe chargeback. So we wanted to take a similar approach because again, we didn't want to interfere or slow down our customers. So in that, it has a kind of permissive mode, and it has this concept of deny levels where there's off, low, medium, and high. And then inversely kind of related, each of the policies has a severity level assigned to it of low, medium, and high. So when the deny level is set to low, only policies that have a high severity are actually denied. Everything else is informed. So we'll get a Slack alert that will say, hey, you failed this, you failed this, you failed this, you failed this, but you passed this. And that makes it okay. We didn't block you at Kubernetes, but we're still gonna send the alert to Slack. And then we have some fun stuff where we have like a default Slack channel that gets targeted for alerts, but then users can define their own Slack channel targets via annotations on their namespaces. So this picks it up and then sends it to there too, so that their team can get those notifications in a passive manner. Kubernetes doesn't yet support a way to inform you on an admission allowed response. Only if there's a denied can you provide feedback at the like kubectl layer to the user. I've talked to some of the folks in some of the working groups there, trying to develop some patterns around maybe doing a KEP for that, but we'll see. Here's an example of what the Slack alert looks like. At the end of that, you see that there are these TKE codes. That's another little fun thing that I came up with that I kind of stole from the shell checker script that's out there on the internet to like lint your shell scripts, where we have an FAQ where those codes are defined. And when you get a deny at the Kubernetes level, you get a message back that tells you the individual policies that were checked, whether you passed or failed, and a related TKE code. So you can take that TKE code, go to our FAQ page, look it up, You see a description of what that policy looks for. You see a description of why it would be denied, and you see a description of how to fix it. And again, empowering our users to solve the problems themselves. Less things that I have to answer, less things that my team has to answer. Overview here of what a mission controller looks like broken down into different pieces here. Everything highlighted in a magenta is something that my team has to manage. So we have the user here, API server, that's a give me. Everybody has to use the API server. We have a webhook config. So there's kind of two major kinds of dynamic mission controllers. There's a validating webhook and a mutating webhook. This is validating, yes or no, doesn't change anything like a mutating webhook. And that basically defines what Kubernetes objects am I watching for, what actions on those objects am I watching for, and it kind of gives you a way to implement a selector to confine those things a little bit more, to say only if a namespace has a certain label do I want to look at it and actually implement the admission logic on it. That gets forwarded to a service and then to the actual admission controller itself, which is essentially an API server. Brings in a request object from the Kubernetes API, runs your logic on it, processes it, builds a response in a specifically formatted JSON structure, sends it back to the Kubernetes API server as yes or no. So we're managing the webhook, the service, the webhook server itself, and the policy. Once you have it all written, you don't have to write it again every day or anything, but it's still pieces to manage. So here's an example, cut off a little bit, but of what an individual policy for our TKEV tool looks like. Again, written in Python, simple things. We basically have a policy object class here, and then we're basically creating an instance of that class. Every policy has these common attributes, and then a method that actually processes the logic for that. And again, for Kubernetes objects, it's just a JSON structure, just parsing that. It's easy to check, does this structure contain this thing or that thing in this way or that way, right? And then we're initiating the instance of that object down here, and that goes into the main policy engine logic to say, let me process everything. When I get a request in, does it match my target of this, 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 or this? Okay, I need to apply this policy, not this policy, not that policy type thing. So I mentioned OPA, Open Policy Agent. These guys are doing some really cool work. I wish I'd have found this sooner. So OPA is a general purpose policy engine that goes beyond the scope of just Kubernetes. You can see down across the bottom, this is just a limited subset of the things that are integrated with OPA at this point. And it's built in such a cool way to where you can have it as a library, a sidecar, host level daemon, the admission controller for Kubernetes, integration as a mixer plugin for things like Istio. It's very powerful, very extensible, right? They use this really weird declarative language called Rego. If you're familiar with data log at all, it's very similar to that. It's weird and it's almost too easy. But it does have some complexity to it just because it's a little bit different than most of the languages that we probably write stuff in day to day. But essentially you see a structure over there very similar with OPA as far as the mission controller experience on Kubernetes to what I talked about with the TKEV tool. But we'll bring up this same slide from an OPA perspective. Again, things highlighted in magenta are things that my team has to manage. Things that aren't highlighted in magenta are things I don't have to care about. So you can see here, the policy is the only thing that I really have to care about here, which if you're like us and you have a small team and a big company with hundreds and thousands of developers, that's hours saved across the board right there of not having to worry about writing your own tool. So if you were to start this journey today, look at OPA. It's easier. And those guys are really responsive, very active in the community. They have a Slack workspace that you can reach them in, and the lead developers and even the co-founders are very responsive and very active there. So reach out. Here's what that same policy looks like written in Rego for OPA. It's a few less lines of code, but it is kind of a little bit intuitive if once you get into it. Not too complex. I won't go into details here, but look it up, go online, check it out. I've got on my GitHub profile, I've got a OPA demo, so feel free to check it out there. I've got some general, like, easy policies written to kind of demo it out. So here's one of the big differences between feature set with TKEV and feature set with OPA. Now, I'll touch on two things here. OPA does not have those cool Slack features, and it doesn't have that permissive mode with the concept of the deny level, right? So that's one of the things still trying to figure out. Do we take those things and build them into OPA, or do we open source our stuff and hope somebody else does that? Or do we integrate OPA as just a library inside our policy engine? But there's this concept of a Kubernetes object cache for OPA. So one of the things when you start looking at a validating admission controller is every request that you have defined for the objects that you have defined in the webhook configuration are going through your API server. That can be expensive depending upon how active your clusters are, how big your user base is, right? So doing things like calling out to an external API in the middle of that admission control workflow is costly. That slows people down and says, okay, we're talking milliseconds, maybe a second, but when you have hundreds, thousands of developers all making cool things on top of Kubernetes, that cost starts to grow. So they figured this out in a really cool way. They have a sidecar that constantly goes out and polls the objects that you tell it to across a Kubernetes cluster. And it keeps those in a data structure that you can easily parse with their Rego language. So you can start to do things instead of a simple policy like, does this request object, this pod specification, have a liveness probe defined in it? You can start to do things like, does this ingress object have a host definition that's allowed by a whitelist in a config map on a namespace? So you can start to split things up and say, we want our customers to be able to bring their own certs, bring their own DNS type thing. And they have a whitelisted group of domains that they can create ingress endpoints in. This tool can do the work to say, did you really create it in the one that you're allowed to? Or are you trying to, be sly and get something biased? So it's really cool things that, really cool way that they fix that problem of the cost of an external API call, which is really neat. So now I'm going to stop talking and get to the demos here. And hopefully the demo gods are kind to me. I did discover one problem with the guest Wi-Fi here. It proxies some connections and it broke one thing. So I've got that disabled right now and hopefully the rest of it will work. All right. But I wanted to take a second here to talk about how I'm actually going to do the demo today. And that's with a tool called Kind, which stands for Kubernetes in Docker. And it's a really cool way to run spin up a Kubernetes cluster, multi-node HA Kubernetes cluster, right? Even with a load balancer to balance API requests across your master servers in a conformant way that is basically built out using kubeadm. And you can even define and influence the kubeadm configuration there. So you can do some really cool things way beyond something like Minikube there. So just want to take a second to give those guys a shout out. Really cool stuff. So not that screen, this screen. All right, this will be a little fun because I can't see what I'm doing. Give me just a second. Let me know when it kind of becomes readable for you guys. Still not readable.
I don't think so. Somebody at Sales Loft can probably answer that better than I can. All right, so I've got a 3-node cluster here, 3 worker nodes. And I've got some namespaces defined here. You should see an open namespace, a TCAP namespace, a test 1 and a test 2. And on the test 1 and test 2 namespaces, you should see some labels there that are basically how we're enabling the admission controller for those objects in those specific namespaces. So I'm going to run through this really quick just to kind of show it in action a little bit. But we'll do an example with TCAP first. And I've just got some predefined workloads here to kind of test out the different functionality of the tool. All right, so really simple. Created an object, right? Or some objects. We'll jump over here. So we can deploy simple workloads, and then we'll try something a little bit different here. All right, so it looks like the proxy stuff's still messing around with this. So it might not be as eventful as I expected with the demo here. So what I'll do is see if I can scroll back here. And bring up an example here. All right, so here, probably still not as readable. Here you see, this is basically the logs from the admission controller itself. And just imagine that you see similar messages sent back to the end user when they run something like a kubectl apply, like I did over there. So essentially, we're tracking what the denial level is set to. And then we're going through and we're showing an example of the policy test for each policy defined here. And again, we're getting a pass or fail. We're seeing what the severity level is set to for that individual policy. And then we're getting kind of a readout, a short description of what that policy is checking for. And again, the TKD code, they can go back to the FAQ and be referenced to what's up there.
So real quick, so you're saying that when this happens, so users not part of your Slack channel forget Slack notifications, but they being the channel.
No, so it is kind of a, we communicate out, hey, if you want to get Slack messages, you need to go out and you need to set an annotation on your namespace that has basically like your Slack incoming workload URL defined there. And the tool will detect that. So it'll say when the request object comes into the admission controller, it'll detect what namespace that object is targeted for. And it'll go out and look and say, does it have the annotation? If it does, add that Slack channel to the array of targets for Slack alerts. If not, send it to our team. And then we still, like for us, it's still important for us to kind of keep an eye on things. So, you know, if we see one customer that has a bunch of alerts coming through, we'll say, hey, let's set up a meeting and let's go over what you guys are doing.
You're not actually blocking the traffic of having a lot of code or various code or anything that you're running in policy family. Are they being denied their
For certain things, yes. So that goes back into the deny level there. So here, this is an example of the deny level low, which means only policies with a high severity are blocked. So in this example, we see the only one with a high is no privileged security context for the Hello Kubernetes workload, right? So that means that there's no privileged pod definition for the security context for that pod, right? But that's something that we do want to block on initially. Now, as we mature as a team supporting the platforms, and as our customer base matures for writing workloads for Kubernetes, we'll be able to turn that deny level up and deny on more things. But we wanted to start with more of an informed stance.
So you're running locally.
Yes.
And the point of using OPA instead of that other one is that you wouldn't proxy your requests to like some other server. So everything here is happening locally.
Yes.
What is being blocked by a proxy?
So it's the call out to Slack here.
Okay.
Yeah. I disabled some of the bits and it gets things a little bit further along, but demo gods are not kind today. So, and again, this stuff, not the TCAP bits, but the OPA bits are available on GitHub profile. If you're on Tech404, reach out, or even on the Kubernetes Slack workspace, reach out to me on there. Phoenix Lee with and Searcy. And I've got cards and some TKD stickers up here too. But any other general questions around this concept?
Have you found achieved its purpose, or has there been some cases that people like it's getting annoyed, like, oh no, lighting is broke, I'll just put some bullshit lighting is broke, something that has nothing to do with the app, and it's like, what's the effect of that?
So like this is something that we're still in the stages of rolling out at large, right? Like I'm not going to say that we've been running this for a year and everything's awesome, right? It's something that we're being very careful rolling out with because it can be impactful to our work streams, right? So we're being very careful about that. And that's kind of one of the things. This is a way to provide a front door check for our customers bringing their own workload to where they don't have to slow down. So is it going to check for everything? No. And you can get advanced. Like I said, with something like the pod disruption budget, does a pod disruption budget exist? Sure. All right. Is it configured correctly? Things like resource limits, different things like that. You can get a little bit more advanced on some of these things. It's like, does this thing appear in the YAML? It's hard to go beyond that. But again, if our customers are going around and circumventing things like that, this tool has even done its job in that case because we have provided a tool to help stop that, and they have specifically chosen to go against it. So if they have a workload failure because of that, not my problem. So that's an interesting question. A lot of these, for a lot of the objects, workload objects inside Kubernetes, the structure of the spec is very similar, right? There are a couple things that are different here and there, but for things like, is my image definition, coming from a known good source, registry, resource limits, things like that. Those are things that like pods have, right? So that applies to stateful sets, deployments, daemon sets, things of that nature. Now, when you start getting into other Kubernetes object types, like a pod disruption budget, that's a completely separate thing that has a completely separate structure. We haven't had anything come across like that yet. Is to say why we haven't tackled that specific thing. It is, we do kind of have the ability and the flexibility with the TKEV tool versus the OPA tool. Since we have that deny level concept, we can have, say, a more strict deny level in production than we have in development, right? But we also have the ability to enable and disable individual policies for an environment as well. We also have that break glass scenario where we have a prime time, say like our point of sale for our stores. We have an issue with that. We think it's related to this tool. Just remove the label on the namespace, figure out what happened later, but get things working. Yeah. So some of our teams, some of our development teams have their own dedicated SRE group, right? And they, in some cases, know more about Kubernetes than us as a platform team, which provides some interesting scenarios. Um, but yeah, and that's one of the features that we're actually talking about baking in is so we have the concept of the deny level, but it's kind of set for cluster wide, right? Set globally at a cluster level. So some of our customers are like, well, you got it set to low to start with. Can we set it to high? So we're looking at building in that feature again, where they can annotate their namespace to go equal to or higher than what the global is for the cluster and kind of turn up the knob on their own. So we've tried really hard not to do that. One of the reasons why my team was like started down the Kubernetes track in the first place is we see a lot of these kind of shadow groups that's like this dev team needed something. They went and got Mesosphere. This dev team needed something else. They got Docker Swarm. This dev team needed something else. They built Kubernetes on Azure. This other team's using GKE. We're a big company. We got lots of dev teams, lots of people doing different things. And a lot of those people had major failures because they're not platform teams. They're development groups, right? So we wanted to provide a place that kind of conforms to best practices and things of that nature, where people don't have to worry about that. You don't have to worry about the platforms in general. It's a Kubernetes dial tone service. I want Kubernetes, give me. And we've been pretty successful in that so far. Now, we do have some customers that have some really peculiar needs. And in that, we kind of go off of our norm of larger multi-tenant clusters, and we spin off a single tenant cluster for them because whatever they're doing is such an anti-pattern or brings in much more risk than what we're comfortable introducing in a multi-tenant environment. But we still combine everybody to a namespace and quotas and things of that nature. All right.
Our next speaker's gonna go ahead and get set up. Sorry. Our next speaker's gonna get set up. You guys want to grab some more pizza, drinks, or anything want to set up? So not really staring at them. We'll get started in 2 more minutes. I'd say, so for us, we look at it as a part of the platform. So whoever is responsible for managing the platform. Now, the policy definition itself can come from anywhere. Like we hope to eventually have our developers saying, hey, we get this big issue, we'd like to define a policy. And you guys will sure. But I see it trying to be managed as close to the platform itself, whoever made the platform itself. The Kubernetes. We're almost 100% yeah, I have my cards there. Feel free to shoot me an email. Sure. Do you need me to forward slides or anything? Are you good? Yeah, I'm good. You want to play what I'm doing or whatever you're doing? Yeah. All right, everyone, I'm ready to start. Hi, everyone. Great job. Yeah, I got it. Yeah. So yeah, a shameless sales pitch right up front. It's just so it's a Sprung One tour in here in Atlanta, and the agenda is pretty awesome. There's a lot of good speakers coming up and doing actual live demos on code. So not like me. So my talk is not going to be like Joe and not that technical. It will be more of like architectural. I won't get into actual demos today, and I think demo gods are raining already. But yeah, June 13, 14, 2-day. It's $100 event, and you get a 2-day pass for that. So if you guys are interested in Spring and Spring Framework talks, it's interesting over there. So I'm going to talk about the evolution of enterprise API gateway in the era of containers, Kubernetes, and cloud. And I'm calling this part 1 because, I don't know, it's 8 o'clock, so how much time do I have? Probably 35 minutes, 35 minutes. It is, so I'm kind of considering as a 2-part talk, and hopefully I can come back and do the second part. But I'm going to give myself 37 minutes because I'm pretty peculiar about numbers. And 37 adds up to 1, and 1 is my birthday. So, and it's part 1, right? So I'm going to give myself 37 minutes. My name is Mayuresh Krishna. I'm a senior platform architect at Pavil. And I'm senior front-end Googler as well, because that's how I get all my job done, by Googling. You can find me tweeting at Mayuresh Krishna. I do that because I tweet my tech memes on Twitter, because all of my friends on Instagram don't like tech memes. They like models, fitness pictures, or cats and dogs. So that's what I tweet. GitHub Mayuresh Krishna, blog mayureshkrishna.com. And the reason I have that, I don't really have much there over there. The reason I have mayureshkrishna.com is because it's a popular domain name. I want to keep it, right? It's such a popular domain name. I don't want to take it and like years later, I'm trying to get it, and I cannot get it, right? But you can call me MK, right? Mayuresh Krishna is popular, but it's hard to remember, right? That's why you can call me MK. And I want to tell you guys a story about my name, right? Why MK, right? So when I was born, my parents gave me, called me Ricky as my calling name. Then I went to first grade, and my dad enrolled me as Rohit. Nobody knows that. Only my school friends know that, right? That I was called Rohit when I was in school. Yeah, I know, right? We worked for like, what, 8 years together? Yeah. In second grade, I found out my calling name is not actually spelled as R-I-C-K-Y, it's spelled as R-E-K-E-E. So I was like, what? Okay. That's when I started writing my name. So in eighth grade, my dad changed my name to Mayuresh Krishna. And why was that? I don't know. He liked numbers too, right? He decided that this number works well in terms of naming. So he called me Mayuresh Krishna, and that's the name I've been using these days.
But when I came to US, I thought like it's really hard for people to remember my name, so I should call myself MK, right? So that's the story of my name. And the reason I tell that is it's great to have so many names, because if Thanos would have killed half of the universe, I might have more chances to survive, right? Right? No, this is not the this is the Infinity Wars. Who's going to the end game tonight? Tonight? Nobody tonight? All the spoilers will be out by tomorrow morning. So don't use your phone. Don't check your messages. Yeah, you gotta go on internet blackout if you want to use it. But the whole story is I'm going through an identity crisis, right? And that's why, like with all these names, I'm going through an identity crisis, and it's probably not just me. API gateways are also going through an identity crisis. So the long story short, the whole thing about this whole naming thing was to tell you to make this point that API gateways right now are going through an identity crisis. And that's a really great blog post by Christian Pasta. And he has really good content about what those crises are and how he thinks things are evolving. And I'm going to tie in some of his thoughts as well, and other leaders' thoughts as well around API gateways. But by the show of hands, how many of you are using some kind of API gateway in your company right now? Right? Okay. And great. I mean, like we have 4 or 5 people using it. So let's get into it. What is an API management? Pretty simple definition on Wikipedia, that you want to have a way to publish your web APIs and enforce some API policies. You want to have control access. You want to have subscriber community, hopefully going there and using those APIs. You want to collect, analyze statistics, and report on performance. That's like a basic definition of API management. And typically in an enterprise, this is how API gateway used to look like. I don't know, their companies are still looking like this. Their companies are far ahead, and they look completely different now. But does this ring a bell? Does this kind of shows you kind of a typical API gateway pattern, which you would see in an enterprise? You have an API gateway. Can I do this? I don't know. Okay, you have an API gateway sitting in the middle, and your traffic, you might have some kind of web or a mobile or IoT middleware talking to that API gateway, and that comes to your backend LOB's middleware, right? In some cases, if the mobile team is kind of strong enough, they actually go directly to the API gateway and not even have their own middleware in the middle. They are relying on the backend API developers providing them the APIs in such a way that they can easily represent it on their mobile devices. So yeah, I mean, those hats off to those kind of mobile developers. They are strong-willed. But then you also have API governance team in a lot of these API gateway scenarios, right? And they're kind of sitting out there who are locking down these policies. And no offense to Joe's talk, he's locking down policies for at a different level, and it's pretty interesting how he's doing it. But on the API gateway side, traditionally you have these governance teams kind of locking down these API gateway policies, and you have to go through them and make sure when you're publishing your APIs, it goes through their processes and gets approved before going to production, right? So it worked really well when everything was waterfall, right? API governance team and their processes were part of your planning. And when teams were doing requirements and design, they were included in it. And then by the time you get to actual implementation, they would also be part of the whole life cycle, right? But then agile transformation came in, right? People started doing different agile frameworks, Scrum, SAFe, XP, user-centered design. In that case, when these teams started becoming agile, API governance teams started becoming kind of a bottleneck. When you're developing more and more APIs faster, you're still relying on these API gateway team and API governance team to allow your APIs to go through and get published and get changed on the API gateway layer. And then when the microservice architecture came in, and the idea was to go faster, That's why you want to build microservices architecture. You want to do smaller independently deployable services. You want to organize around business capabilities. You want to have decentralized governance. You want to have decentralized data management. You want to have decentralized communication patterns. Guess what? When you do that, and you kind of start building together your APIs or kind of breaking out your APIs in domains, in domain-driven design or by your business products. This API governance team starts becoming bigger bottleneck because now you have more APIs and you're building it faster, right? And you want to go publish it out there on the API gateway. Now you have to make sure your APIs are available to your end consumers fast enough, but your API governance team is kind of slowing down. And traditionally, the API gateways, the way they have been, they are not that automated in terms of like how would you allow a process to go through in the workflow, right? They have their workflows. You have to go through the cycle. You have to go through the approvals, and then your APIs gets published, right? And then the containerization, Kubernetes, and DevOps era came in. The wheels, the cycle, right? Quick question. Do we know why Docker has a fish and container or a whale in a container as their icon, as their logo? Anybody knows over here? It was actually a cool trivia. It was a 9-9 design contest where one of the logo maker won that contest and came up with that thing. This was the question. This was the other one, like the seven spokes on the wheel on the Kubernetes is based off the Project 7 of 9, or based on the Star Trek reference of Borg as Project 7 of 9. But moving on, so with containerization, we have now Kubernetes clusters, and you're building your APIs. Now APIs are not static endpoints, and this kind of started to make that bottleneck even bigger, right? And the point which I'm trying to make with this evolution is the traditional way of doing API gateway, where you have a central API gateway management in using some of the traditional API gateway products like, people will cringe if I say Apigee is a traditional API gateway product, but it is kind of becoming that layer 7 CA. I wouldn't say Kong is traditional yet, but yeah, it's kind of in that direction, but they're trying to do good things now. But traditional API gateways are becoming bottleneck in terms of how we're doing things now, right? It might not be true that everybody has gone through the microservice decomposition and everybody has already started building their APIs by the product lines. But to some extent, you have this more number of APIs getting developed and getting developed faster, and you want to publish it out to your consumers, but you have this central API gateway in the middle if you're using API gateway, which is kind of slowing it down, right? And what do you want to do? What would you do if one of your cluster or your domain is actually hosted on cloud? Now, you cannot go through that central API gateway anymore, right? Or if you want to go through that, you want to go through your on-prem API gateway and then go back to your actual APIs on the cloud. What if one of the cluster is an edge cluster in some store, right? Or you have many edge clusters in some stores or any edges. Do you want to go through central API gateway to get to those edge clusters? So the whole idea of this one API gateway sitting in the middle with a governance team kind of managing it, no offense to the governance team. I was once pseudo API governance team member, so yeah, I mean, no offense to governance team, but it does not fit right now in this model, in this age. So the idea, the identity crisis, which I think is for API gateway, is this a centralized shared infrastructure anymore, which should facilitate the exposure of all your APIs within the within your different product domains, right? Is it a centralized infrastructure to allow service-to-service traffic? Should it be? Does enterprise API need to be bloated API management deployment with all the things like dev portal, process flow, monetizations. How many of you are actually monetizing your APIs and using those features which comes out of the box with some of these API management products? Like unless you're Facebook or Twitter, is anyone monetizing their APIs right now over here? So the products come out of the box as a bloated product. Do you really want to use that bloated product as an API management? And do we need a centralized API governance team managing all these decentralized product teams' APIs, right, in one place? So here's what I think, what we are looking for as we're going towards more decentralized way of developing APIs, developing your products, right? You want something which is a decentralized gateway for decentralized teams. You're looking for something which is very lightweight to deploy. Think like edge use cases. You might have something where you want to deploy it on a 1U or 2U racks, or even smaller, and run your API gateway along with your actual APIs in the edge cluster. You want something which supports multiple modern protocols from SUP1 up to gRPC, and maybe even low-level TCP, where you can have API gateway actually talk to your databases in some scenarios for some reasons, right? You want to have, since we're developing now microservices, you want to have dynamic service discovery. So instead of every time you publish an API, somebody goes and adds it to the API gateway, you want to have a dynamic service discovery that you add an API and you make it available, it shows up on the API gateway. When you're doing that, when you're building so many microservices, you want to have good, robust observability on those APIs, and an easy way to debug, right? When you're decentralizing, when you're increasing the number of APIs that you're publishing, you want a better way to debug those on the API gateway as well. Versus you have really good observability, you have really good debugging at the Kubernetes layer, but when you get to the API gateway, you don't have that information. And you want to do advanced load balancing and support great reliability features and great filtering features like circuit breakers, retries, rate limiting. So you want to have all the features which API gateways present in the traditional world, that all these filtering capabilities, but you don't want to, you want to go to something which is a more decentralized gateway, more lightweight, more easily deployable in edge cases. So that's why I think Envoy proxy kind of acts as a rescue for API gateways. And I mean, pretty much a lot of companies are kind of relying on the Envoy proxy, and I'll kind of touch upon that. But if you think of it, Envoy proxy has a mission statement that network should be transparent to application, and when network and application problems do occur, it should be easy to determine the source of the problem. And if you think it's a hard problem to solve. We'll kind of try to see how Envoy proxy is trying to solve that, right? And how Envoy proxy is attempting to take each of these problems and facilitate an easy approach to it. So in terms of why Envoy proxy, it is, if you think of it, there are other options out there, right? But the good thing about Envoy proxy is like out of the box architecture, out of process architecture, which you can deploy on its own, and not a framework which you have to attach with your code, right? So it runs independently, deploys independently, and you don't get probably attached to a particular framework when you're doing that, right? It's built on modern C++ code. It's lightweight, it's fast, and it's productive. It has layer 3 and layer 4 filter architecture. So you can do TCP level filtering as well as apart from the HTTP. So as I was saying, you can do MongoDB, Redis, stall replacement, TCP rate limiter as well with the layer 3, layer 4 architecture on Envoy proxy. Layer 7 is pretty easy on this one. HTTP2 is there as the first thing. It's not that some of the traditional API gateway like Apigee, they're trying to have HTTP2, but it was built as HTTP1, and then they're trying to go towards HTTP2 and build HTTP2 as a layer 7. But Envoy proxy was built as HTTP2 first, and you can even do gRPC as well as HTTP1 to gRPC bridge with Envoy proxy. It has decent service discovery and active health checking built into it, so it will whatever you add in your layer 7 filtered or in your path, it will actively do checking on that, health checking on that, and when you're deploying Envoy proxy with dynamic discovery, it will discover all your APIs which are registering to your cluster. Advanced load balancing capabilities. So I mean, the Envoy proxy kind of checks all the boxes which you want to have in a very lightweight, fast API gateway, right, in your edge proxy. There is a great talk by Matt Klein, who is a senior software engineer at Lyft. He's part of the original Envoy team before they put it out as open source. But he has a great talk on actually which goes into each of these features and goes into the technical details of that, and kind of explains how it is trying to perform that and how it's trying to solve that. So it's a great talk. I'll share the slides, and if you guys want to look at it, it kind of gets into the depth of how Envoy proxy is doing these things at different levels. So I'm not saying that Envoy proxy is the only option, but with so many projects which are adopting Envoy across the board as their edge, as their proxy into Kubernetes, not just Kubernetes, even in Cloud Foundry and other tool chains, it is now considered as your universal data plane, right? I mean, it is kind of accepted. You can say that as a community, everybody has accepted Envoy as a universal data plane, right? Matt Klein actually in 2017, I believe, wrote about it, that on the proxy can be a universal data plane. And yeah, I mean, a lot of different projects have adopted Envoy as their universal data plane. And so it's kind of a good validation from the community as well that Envoy proxy is something which works for everyone and in these use cases. So it was battle tested by Lyft. They have really great native KX integration to deploy Envoy proxy, feature rich and extensible, and it is considered as universal data plane at this point, right? So that's why Envoy proxy is something which I think can be a really good way of getting into the evolution of API gateways, which traditionally was a monolith deployment sitting in the center. But how it could look like with Envoy proxy. So let's look at that. But before we look at that, let's look at one of the API gateway patterns, which a lot of people are looking at. And especially with microservices, there's a lot of suggestion going on in this direction. This is an API gateway pattern, which is published by Chris Richardson. And what he is recommending is that when you have these microservices on the other side, you want to have a single point of entry as API gateway to talk to those microservices. And I think my challenge with that approach is that if you do that, you're kind of going back to the same old way of doing things. You might have now a lightweight API gateway sitting in the middle, but you're still trying to create a single point of entry for all your APIs, and that becomes, and if you look at the definition, it's the single point of entry for all clients, and by definition, a single point of entry in a microservices ecosystem enforces centralization, enforces coordination, and single point of failure. So do you think this is a good approach? I'm not sure. I mean, for me, this is not like a prescriptive talk. It's more of like exploratory talk. I want to understand. I want to kind of bring that ideas out here and see what you guys are thinking about. What you guys are thinking about in your organization for API Gateway, and see if this kind of makes sense to you, right? Is this something? is this still a great approach to do API gateway? Or with Kubernetes, with cloud, and with all the containerization and microservices we're doing, is it a good idea to have a single point of entry for microservice ecosystem through one API gateway sitting in the middle? The other variation of this pattern is you would have the web API gateway or mobile API gateway or public API gateway as we saw. And this is something which companies have been traditionally doing. They have their web middleware sitting over there. They have their mobile middleware sitting over there, interacting with the central API gateway. But in that case, the web team, the web mobile team, they have their SLAs and SLOs managed around those APIs and measured around these APIs from their point of view. But what about the product teams who are actually producer of those APIs, right? How does the, for an example, the producer of the API who is, say, producing an order API, how do they measure their SLOs? And how do they make sure that the policies which they want to apply on these APIs for their consumers, which could be web, which could be mobile, as well as other public developers, how do they make sure that those are applied? If we just go by this pattern, where you have backend or front ends where the web team, the mobile team are managing their APIs and just directly hitting your backend APIs of the product teams. So again, there's no definition, there's nothing out there called as domain gateway pattern or something like that, but I'm just thinking out loud. Can we have something like a domain gateway pattern, right? Where it's an entry point for accessing a group of APIs, providing a domain business capability. It's not a single point of entry. It's a point of entry for a group of APIs for that product domain, right? It's no longer that entire enterprise is going through one API gateway. Now, product teams are exposing their API through an API gateway, and they're producing their set of APIs through that, right? And then that they are independently managing that gateway, they're independently managing the contracts with the consumers, and they're independently managing their SLAs and measuring their SLOs with the consumers. So let's quickly see, is this how it could look like, right? If we have, I don't know if it'll show on that, but if you have now API gateway sitting at the edge of each of your product teams cluster, it could be namespace, it could be cluster. But the idea is that your, say, order DevOps team is producing their APIs, and they're also exposing their APIs through the gateway, right? And the idea is not to have endpoint for each of the different APIs out there, but the idea is to kind of group it at the domain level or the product level and expose that as from your API gateway, and that product team manages their own API gateway and how they publish and expose and how they drive the policies on the APIs, right? And this was the reason I was asking you that question, Joe, that are there teams right now who actually want to manage their policies themselves, right? And kind of drive that for my product domain, I want to enforce these policies. Your example was great. I was more on the technical side, and I'm kind of trying to go towards more on the business side and say, as a business unit, I'm producing these APIs. I want to manage the policies, how I want to expose these APIs to my actual customers. Say it again. So you're saying that this team might not have. Sure. Yeah. And what I think is you would still, if you are exposing some public APIs, you would still want to have that so I'm not saying this throw away your governance team, but keep that governance team engaged as one at the public API exposure level, and help them, or they should help the teams to enable individual API gateways. And right, so instead of becoming a governance team, they become enabler team for these gateways on individual product teams. So again, it's a thought. Do we really have to have a centralized API gateway? Or do we move towards more domain-based, product-based gateways, exposing their business APIs from there? And that product team is managing their API gateway along with it. Right? An alternative approach could be you still have a central lightweight public API gateway in the middle, but it has very basic global minimal policies applied. All the other policies are kind of driven by individual product teams, right? So maybe if this is too much to go to, let's start with maybe making the central API gateway very lightweight. There isn't much API to API policy changes. There's just a couple of global policies, you apply those, and all the APIs which are exposed by these product teams, they just inherit those common global policies which you want to apply, and rest of it is kind of driven by that product team. Other product team might want to have a different rate limiter than the customer product team, or they want to have different kind of filtering on their APIs compared to other teams. Yeah. It does not make it Envoy specific. What I'm trying to go towards is that if you are already using Kubernetes in your deployment architecture, then Envoy fits really well in that architecture. And Envoy kind of natively sits in there very easily, and you can use it. And in fact, to say that if you're doing that, you can even actually do it with your monoliths as well, right? So you can bring Envoy API Gateway cluster as a standalone sitting in there, right? As a standalone cluster or namespace, actually proxying your monolith as well in the middle if you want to, right? But if you're already doing Kubernetes and you are still integrating with a monolith API gateway, I think there is a good use case, or I think it's a good use case to have Envoy being your API gateway for your APIs you're exposing.
How would this, like using something like Twitter as an example,
Right.
where you got a whole bunch of API methods and they're breakers, amounts of plan you're on, relationship you have with Twitter and paying for or not paying for. It strikes me as that would be difficult to implement using this model because you have to have a central pass-through point that enforces, like if you pay for a certain service level or a certain level of capabilities, like that has to be managed in a sense of like each team can't know what.
Sure. Yeah, I agree. I mean, that's the scenario of where I'm saying that for the public API gateway, you might have public APIs for your external developers. Example, Twitter or Facebook's, they actually use they expose their APIs as public APIs for third-party developers. That's where that API gateway makes sense, right? To have a public API gateway. But for most of the traditional enterprises where you have web, you have mobile, some IoT popping up here and there, in those kind of traditional use cases, you don't really need to have one public API gateway which is exposing everything, right? It's already sitting in DMZ. You can expose it. You can have your web or mobile middleware come in and talk to your API gateway at the cluster level. So yeah, I mean, that's what I think, in case of public third-party developer scenarios, you still need to have that public API gateway. And it could be something which is where you might have a central public API gateway, but is a very lightweight pass-through global policy handler. But all the individual product level requirements are kind of driven by that product team. But there is a challenge, right? Envoy proxy is great in terms of it's lightweight, it's fast, it has all the features which we want from filtering, layer 7 filtering point of view. It is already accepted as a universal data plane, but there's no out-of-the-box control and management plane with Envoy proxy, right? So you have to, if you want to enforce policies or use the filters of Envoy proxy, you have to manage those configuration yourself, right? And push those configuration yourself. There's no out-of-the-box control plane which can do that. And that's where all these different projects, open source projects, have kind of come in, and they have adopted Envoy proxy and built really great control plane on top of it. So you could there's a great Solo.io's Glue project, which open source project, which takes Envoy proxy and builds API gateway control plane on top of it, right? On top of Envoy proxy. Same with Ambassador. Ambassador was actually the earliest one who actually came in and built the control plane on Envoy proxy as something for API gateway. Right? So there are a couple of other projects as well which are doing great work on the control plane side to make Envoy proxy usage more easy, right? So instead of you managing the configuration through your own YAMLs and policy changes, use some of the control planes which these guys are building. Yeah, just a quick look at Glue, and I like Glue because I've been, like, when I was going through this this presentation, I was trying to build some demos and understand how to do that. For example, for Envoy to have service discovery, you have to use something called as XDS, which is the data discovery service. And to build that discovery service, it's not easy to build that discovery service. You have to go through a lot of code to actually build that discovery service so you can attach it to your Envoy proxy deployment. Otherwise, like for example, when Lyft started, they typically, or for a long time, they did static model. They did not have the XDS or data discovery for their APIs, and they would actually go through non-disruptive change cycles to kind of push out any new APIs. But so these projects which are built on top of Envoy proxy as control plane actually is making those of things easy. So yeah, check out Glue, check out Ambassador. One of the great things about Glue is you can do microservices. You can actually plug in your cloud functions as well, or you can talk to your monolith, even build hybrid API calls through Glue. It's a great control plane, which I like. Questions? Pretty much like 37 minutes, right?
All right, so I know HCS more design is like Searcy,
Right.
Did it use policy?
So H2 can also be used to control some of these policies because it has that control plane as well, which you can use to drive the policies apply. But it works more on the service to service. So like when you apply your policies through H2's control plane, it will inject as a sidecar to the actual API sitting out there internally, but not at the edge at the proxy level, right? To bring your policy in and kind of apply those policies at the proxy level, you want to have something which can push that changes out to your proxy, right? Instead of just as a sidecar on individual APIs. So for example, you want to have a cluster level policy injected, for which you cannot do that with Istio. So one of the good thing about Glue is it integrates with both Envoy and Istio. So you can build service mesh for your service to service call, and you can build your edge proxy API gateway through Envoy, and you can push your policies accordingly to either of those. One other thing which I wanted to do, so the idea of part 2 was kind of trying to get towards more understanding the service mesh architecture, go towards kind of defining inter and intra-domain services call, and where you would want to have service mesh versus where you want to have API gateway to API gateway call. And then kind of one thing which I wanted to touch upon is those two projects, Solo and Ambassador, and how do they compare to each other. But yeah, any other questions? Sure.
So basically, how is it different than RPG proxy? I mean, there's
So-
also balancing your APIs, and you can redirect APIs to a different approach, right?
Right. So if you look at it, Apigee sits in your Kubernetes architecture. Apigee would still sit somewhere in the middle over here, right? Right. And then you would have Apigee as your single point of entry for everything. Apigee and Apigee is started doing something called as micro gateway now. But if you deploy a traditional Apigee API gateway, and if you want to do this kind of pattern, you're pretty much deploying a pretty huge monolith on your cluster, right? And if you want to go towards cloud or edge clusters, you pretty much cannot deploy Apigee as your gateway on that environment, unless, especially in the edge cases, right? With Apigee micro gateway, they're trying to go towards the model of Istio, but that kind of still injects your gateway as a sidecar with your APIs, right? So I would say that the only thing which I would say is why I think Envoy proxy makes sense compared to Apigee is it has a pretty good native integration with Kubernetes versus Apigee is trying to now build it as part of that. Their traditional product does not have it. With their micro gateway, they're trying to build that integration with Kubernetes. Any other questions? Maybe thoughts, like what do you think? Is that like completely radical and like I'm just having a pipe dream about people doing their product gateways versus this is something which kind of makes sense if companies or your organizations are moving towards product-based API development?
So my experience is at Home Depot, where not everyone is on Kubernetes.
Sure.
It's hard to argue against Envoy. Envoy is like incredible.
Right.
But like what I think about is like one, the talent there, you know, like if you try to go towards cloud native, you have to go through like containers and CI/CD and Kubernetes before you get to Envoy.
Mm-hmm.
And those are all learning challenges. And then also, like I know one of the challenges that the team that I was working with had was if you do want to go towards like microservices, maybe you do the managed version first, you go to like Elastic Beanstalk, App Engine, App Services, whatever. So you put like a microservice, maybe a container on there, and then that endpoint is going to be exposed unless you lock it down with like Cloud Endpoints or Apigee or whatever API gateway you have, and you don't have access to the infrastructure. And that's like a good way to go towards microservices by doing like the managed version first, and maybe you containerize it, but you can't actually deploy Envoy in that environment.
Sure. So I mean, like you're saying, and if somebody wants to go this approach, that okay, before I kind of break down my monolith and go towards containerization, let's build that API gateway. That's really hard to go towards, right? That's
well, you can go like containers, do
right,
microservices,
and then go towards building an
managed way rather than in Kubernetes. It's a
right,
different ecosystem,
right.
and you don't get to do this, so you
Yeah.
still need like an Apigee or Cloud Endpoint.
Yeah. But in this case, I mean, in that case, like, you're actually going towards this model, and you're probably not using Envoy, but you're using a different your product-based API gateway, right?
I mean, sure, if like the API gateway makes like everything for it's a monolith, you can have like a microservices architecture below it, and you know, if it fails, then that fails, but there's less like single points of failure on that path.
Sure.
So there's value in it.
Yeah.
Just one comment for me. The thing that we've seen, and I have a lot of people is super valuable, the centralizing on kind of common data plane across lots of different things, whether it's routing and Kubernetes,
Right.
Edge-based services, API gateway, is having that common data plane where you can like move policy implementation from inside your application to inside the routing data plane.
Sure. Yeah.
You can kind of start to separate things. And as you migrate from existing legacy monoliths to microservices and everything, all of that's abstracted from
Yeah, yeah. But are you seeing T-Mobile adoption of Envoy for some of those use cases?
Yeah, so, I mean, we run Apogee.
Right.
And we have the, adapter for Apogee.
Apogee.
That we're using, and then, we're getting the bits for Envoy and Cloud Foundry now as well. So we're starting to see, all the pieces kind of come into place where we can, circuit breaker logic or
Right.
whatever else that we want to in a common way across all.
Yeah. All right. If anybody have any other question, thoughts? Otherwise, I'll start running towards my 10 o'clock show for Endgame. Thank you.
Thanks much. All right, that's all we got, guys. Thanks for coming out. We will be back here next month, probably on the 22nd, tentatively. Still open for speakers, as I said. So hit me up or on Tech44 through the Meetup. Let me know if you got something you're interested in presenting. That's it. Thanks, guys.